Okay, method of sealed bids. So 4 players, Alice, Ben, Carla, and Daniel, secretly bid on 3 items. Your job is to divide the goods according to method of sealed bids. And be sure to indicate who gets which item and all that other stuff. Okay, so first of all, we know who gets each item. Who gets the Pyraminx? It has to be Daniel. Who gets the used laptop? That would be Alice. And who gets the jacket? That would be Ben. It turns out Carla gets nothing, but that's not true. She gets cash. And that is the magic of this division system. Okay, let's figure out what the different fair amounts are for everything. All right, so Alice says that everything's worth $253. Here's the totals. So how much does Ben think everything's worth? So 150 plus 70. That's how much Ben thinks it, so it's going to be 220. And what about Carla? Thinks everything's worth $84. And Daniel thinks everything's 175 plus 12 plus 60. So he values the whole pile at 247, and that's why Carla gets not much, because she doesn't think anything's worth anything. So that's the way she feels about it. And you notice she didn't know, but it would have been much more strategic if Carla had said the Pyraminx was worth 11 and the laptop was worth $199 and the jacket were worth $64, and she would have gotten a huge pile of money and she still would have gotten nothing. Isn't that interesting? Another thing to notice is that in this particular example, since there are exactly 4 people and everybody's valuing everything at exactly the nearest dollar amount, since every dollar can be evenly divided into 4, everybody's fair share will turn out even. There'll be no fractions, no penny fractions. And so in this case, when the fair shares turn out to be exact penny amounts, then everything's going to turn out without any round off. So that's great. Okay, so we're going to have, for example, $55 for Ben, $21 for Carla. Those are easy, but like 253 divided by 4 is going to be 63.25 for Alice. 247, let's see. 247 divided by 4 is going to give 61.75 for Daniel. All right? And so let's go through, now we know who gets each item, and let's go through the first round. So in the first round, Alice, so I'm going to just call this round 1. There's more than one way to annotate, to note this down, but Alice has to pay $200 minus her fair share. Alice has to pay $200 minus her fair share. So how much does she pay? I just typed that in wrong. It's $136.75 to the pot. So Alice pays into the pot. Who else? It might be convenient to know who else pays into the pot. Okay, Ben receives 65, which is more than his fair share. So he would pay 65 for his item, except that he has a fair share, and that's 10 to the pot. Okay, and what about Carla? Gets her fair share, gets 21 from the pot. And Daniel, he has to get from the pot, but he has to take away the Pyraminx value. 61.75 minus 12 is how much he gets from the pot. 61.75 minus, I might have said the wrong number, minus 12, not what I said. 49.75 from the pot. You can think of the fair share as being coupon number 1. It's like a coupon or a gift certificate, okay? That's how much is owed you. It's a gift certificate that can be redeemed for cash. Okay, so that's round 1. And then what will happen is you'll end up with extra money. So this is going into the pot, and this is out of the pot, and this is out of the pot. So how much went into the pot? 136.75 plus 10 equals 146.75 into the pot, and we had 21 plus 49.75. Why are these not pressing correctly? 21 plus 49.75 going out of the pot. So 70.75 out of the pot. Okay? So we get 76 extra left in the pot. And that is the surplus from the differential. So for example, we've got cheap Carla and we have everybody else. So everybody else values everything more than Carla does. And this is where the surplus comes from. If everybody valued every item at exactly the same amount, there'd be multiple solutions. Everyone would still be happy, but everyone would get exactly their fair share, no more, no less. And it wouldn't really matter who got which item. Okay, so we have the 76, but everybody values cash at exactly the same amount. That's the beauty of cash. So 76 divided by 4 is $19 each. Okay, and that would be like coupon number 2. Alright, everybody is owed $19 from that differential. And so what do the final cash outlays look like? So Alice, so this is stage 2, or the final cash outlays. So she only has to pay $19 less than this to the pot. So she gets a second coupon, so she's just $136.75 minus the second coupon gives her $117.75 to the pot. And B, Ben was going to pay $10, but he's receiving $19, so he gets $9 from the pot. Do you see he flips? He went from being a payer to a receiver because the second round put him over. Okay? And what's Carla doing? Carla was already receiving $21, but now she's receiving $19 more, so that's just $40. It looks like Alice is paying off everybody today. Okay, Daniel was going to take money from the pot, and he is still, but he's also getting 19 more. So we've got 49.75 plus his second round money, so it's 68.75 from the pot. So this is, you're done now, but let's double check as a sanity. Okay, we only have one person paying to the pot, okay, and everybody else taking from. So this is really easy to calculate. If we had 2 of each, we'd just add them up and make sure the 2's equal the froms. But we've already got the 2's added up here. This guy's how much is going into. So Alice is footing the bill for everything else. And so let's just add up these 3 numbers. And again, since we had exactly 4 players and they just did everything down to the nearest dollar, this should all come out completely even with no round off error. We get $117.75, which is exactly how much Alice has to pay. You get to that stage in the problem and you're pretty sure you did everything correctly. You can double check everything, but there's a pretty good chance you did it just fine.